All right, a question a day, day 11. Use the substitution x plus 2 equals 2 tan theta to obtain that integral. Well, always we need to replace the dx as well as just substituting for the x in the integral itself. So we're going to have to find dx d theta. So x plus 2 equals 2 tan theta. Which means x itself is 2 tan theta minus 2, and dx d theta is equal to 2 sec squared theta, and because minus 2 is a constant, so its derivative is 0. And you can go on the formula sheet to get tan theta is sec squared theta, which means that dx can be replaced by 2 sec squared theta d theta, doesn't it? Right? So that's an important thing for us there. You've always got to replace the dx in the thing. Now, the x plus 2, how are we going to use that? Well, you know, experience tells me to complete the square here in order to replace the x plus 2. So I'm going to do that. And if you haven't had that experience yet, well, here it is now. You want to complete the square. So x squared plus 4x plus 8 is equal to x squared plus 4x plus... Now, half of the coefficient of the x is 2, squared is 4, right? So I'm going to add on 2 squared and take off the 2 squared. And of course, I've got the plus 8 that I'd left alone. So this is x plus 2 all squared minus 4 plus 8. So it's x plus 2 all squared plus 4. So I'm now ready to go. I'll just move this out of the way. Delete that, and there we go, we've got some room there. So I'm ready to go now to do this integral. The integral of 1 on x squared plus 4x plus 8 dx is the same as the integral of 1 on x plus 2 squared plus 4 dx, right? And that's going to be the same as now. We can replace the x plus 2 with 2 tan theta, because that's what we were told at the beginning. X plus 2 is 2 tan theta. So that's being squared plus 4, and the dx is 2 sec squared theta d theta. All right, now this is the integral of 1 on 4 tan squared theta plus 4 times 2 sec squared. Oh, my pen's decided to bail out, so I'll just go okay, sec squared theta d theta, there we go. Now I'm going to factorise that 4 out of the bottom line, and this is, I guess, again, experience, but we should be familiar now what tan squared plus 1 is equal to. But I'll just go on the side here and work that through for you. We know that sine squared theta plus cos squared theta equals 1. Everyone should know that. And if we divide by cos squared theta, we get tan squared theta plus 1 equals sec squared theta. So that's what I'm going to do. Wherever I see a tan squared theta plus 1, I'm going to pop a sec squared theta in there. So this is equal to the integral of 1 on 4 times sec squared theta times 2 sec squared theta d theta. All right, so you can see the sec squared thetas are going to cancel out, and we've got the integral of 2 over 4. What's that? A half d theta. And that's just theta on 2 plus c. If you integrate a constant, then you just put the variable next to it. Now, we don't have a definite integral, so we've got to replace back in. So just from back up at the top there, what was our substitution? That's going to be an important thing. and it says that the substitution was x plus 2 equals 2 tan theta. So I'll write that down here. X plus 2 equals 2 tan theta. All right. So what does theta equal? Well, let's x plus 2 on 2 equals tan theta. To get theta by itself, I've got to take the inverse, don't I? So the inverse tan of x plus 2 on 2 is equal to theta. So that's what I'm going to have to put in for theta. This is equal to the inverse tan of x plus 2 on 2, that's what theta is, on 2 plus c. Or if you like, half inverse tan x plus 2 on 2 plus c. Now, this integration could have been done just using your normal knowledge of inverse tan and using the formula sheet to see what happens when you have the right setup for inverse tan. But I followed what the question asked. It did want us to use that substitution.